Hello everyone. Today we are going to find an expression for diameter of bright and dark rings in transmitted system. In the previous lecture we have derived an expression for diameter of bright and dark rings in reflected system. So the difference in reflected and transmitted system is in part difference. In case of reflected system, part difference was 2 mu t plus minus lambda by 2. There is no factor of plus minus lambda by 2 here, only 2 mu t is there. And you also know that in transmitted system, the condition of maxima is this and the condition of minima in transmitted is given by this. And these conditions are just opposite to the conditions of reflected system. So the process, the method is same, just the method of a reflected system. First, we will find the thickness of air film for that nth bright ring, which will be Rn square upon 2r. Then we will substitute this value of t in the condition of maxima, and then we will solve it and we will find the diameter of bright ring. And the similar method will be adopted for dark rings, where the thickness of air film for nth dark ring is Rn dash square upon 2r. After substituting this value of t in this condition of minima and after solving, you are getting diameter of dark ring is equal to this. So if you will closely observe equation number 3 and 4, then 3, this particular expression was the diameter of dark ring in reflected, and this was the condition of bright ring in reflected system. It means the interference pattern in reflected and transmitted system both are complementary to each other. So this is all about transmitted system here. Now what are the applications of this Newton ring experiment? So two main applications are there. One is we can find the wavelength of any unknown source of light using Newton ring experiment. Second one is we can find the refractive index of a liquid using Newton ring experiment. So first we are going to discuss that how we will find the wavelength using Newton ring experiment. So in order to find the wavelength, first the expression for nth bright ring, the diameter of nth dark ring, since this expression is simple as compared to diameter of bright ring, that's why I'm taking here diameter of dark ring. And one more point which you have to remember here, that we are taking only the conditions, only the results of reflected system here. So in reflected system, this equation, this represents the diameter of nth dark ring, and between plano-convex lens and glass plate generally there is air. So for air, refractive index is 1. So diameter is equal to 4 n lambda r. This is for nth dark ring. Similarly, the diameter of n plus pth dark ring, that is given by this expression, and if you will substitute mu 1, you will get equation number 2. Now subtract 1 from 2, you will get this result, and after solving it for wavelength, you are getting the wavelength is given by this expression dn plus p square, which is square of the diameter of n plus pth ring, minus dn square, which is square of the diameter of nth dark ring, upon 4pr. If you will solve it using the condition of maxima, again you will get the same result. So if you want to find the wavelength of any unknown source of light, then you will apply this result. The second one is that the refractive index of a liquid refractive index of a liquid can be calculated using Newton ring experiment. For this, we are going to perform that experiment first with air in between plano-convex lens and glass plate. Then after that, experiment is performed with the liquid in between plano-convex lens and glass plate. So if there is air between plano-convex lens and glass plate, then the diameter of any nth dark ring will be given by equation number 1. And if there is liquid in between, then the diameter will be given by equation number 2. So if you will solve it for mu, then this mu is dn square for air upon dn square for liquid. So using this simple expression, you can find the diameter, you can find the refractive index of an unknown liquid. And one more point which can be concluded from this expression is diameter of any nth dark ring with liquid in between plano-convex lens and glass plate is always lesser than the diameter of the same dark ring with air in between plano-convex lens, because that diameter that will reduce by a factor of 1 upon under root mu. So in general, you can say when there is a liquid in between plano convex lens and glass plate, then the diameter of all the bright rings as well as dark rings, that diameter will decrease by this factor of 1 upon root mu. Means there will be a contraction in the interference pattern when a liquid of refractive index mu is introduced between plano convex lens and glass plate. So this is the application of Newton ring experiment. Thank you.